Hello students, now we will discuss about the topic some important compounds of transition elements. So two main important compounds are the potassium dichromate K2Cr2O7 and second one is the potassium permanganate KMnO4, right? So first we'll start with the potassium dichromate. So first is its preparation and then its oxidizing nature in acidic or in basic medium. So first one is its a preparation. So it is prepared from the chromite ore FeCr2O4 on reaction with sodium carbonate in presence of oxygen, that will give you sodium dichromate plus Fe2O3 and carbon dioxide. Further, this sodium dichromate in acidic medium gets converted to sodium dichromate Na2Cr2O7. Now if we look at this equation Na2Cr2O4 and on other side Na2Cr2O7, so here it's a, if we ionize this in the skeleton form of the equation, it will give you chromate and CrO4 negative, and other side is the dichromate Cr2O7 2 negative. Then this sodium dichromate being more soluble in water than the potassium dichromate, we can prepare this potassium dichromate by reaction of sodium dichromate with potassium chloride. We will get the potassium dichromate which is required. Then is the, if we this chromate and dichromate are interconvertible in, right, depending upon the pH. So if we treat chromate with the in acidic medium, we get the dichromate, and if we treat dichromate in basic medium, we will get the chromate. Then is the structure of the chromate ion, the and dichromate ion. Chromate ion has the tetrahedral structure and dichromate has the you can say two tetrahedral structures are there, right? So that is the consist of two tetrahedral structure, right? As you can see in this screen, it's of dichromate ion and this is of the chromate ion. That's a tetrahedral structure. As we are well aware of this, the methane structure is the tetrahedral. So in the similar structure is the tetrahedral structure of the chromate ion. Now the most important is the oxidizing nature of the chromate. So basic equation is the chromate in acidic medium will give you chromium 3 positive. So here from plus 6 oxidation state, it gets to plus 3 oxidation state, being for 1 chromium it will gain 3 electrons and for 2 it will gain 6 electrons. So it means if it has to gain 6 electrons, of course some reducing agent has to lose the 6 electrons, so that this chromium dichromate will get 6 electron and get reduced to chromium 3 positive. So these are the equations. Now the point is how to remember this equation. We need not to remember this equation. We should have to learn how to get this, the balanced equation. So there is a basic skeleton equation and we will be learning how to balance, because it's difficult to remember all these equations and no need to remember. We have a very logical procedure to learn this, right? And we will learn this, right? Then is the potassium permanganate KMnO4. It's a first one. It's a preparation that's from MnO2. That's it is prepared from MnO2 or and in presence of potassium hydroxide in acidic in the presence of oxygen gives you K2MnO4 and so it's a magnet, potassium magnet. So this potassium magnet in acidic medium will give you permanganate. So this is by chemical way we can prepare the permanganate ion, but we can prepare by the from the magnet ion and by the electrolytic oxidation we can convert the magnet ion to permanganate ion. So it's a simple one. So you need not to worry. I will teach you how to learn this equation, how to balance this, because it's a very otherwise difficult to learn all these equations. ऐसे हर इक्वेशन हम याद नहीं रखेंगे, हम तो बहुत ही हम लॉजिकली हम इसको सीखेंगे, प्रैक्टिस करेंगे और अपने आप लर्न हो जाएंगे. आपको कोई भी इक्वेशन दी जाएगी तो आप बड़ी आसानी से उसको बहुत ही आसानी से उसको बैलेंस कर सकते हैं, राइट? तो हम कुछ इस तरह से सीखेंगे. देन अगेन इज द स्ट्रक्चर ऑफ द मैग्नेट आयन. यू कैन सी अगेन इट्स अ टेट्राहेड्रल. जैसे हमने मीथेन का स्ट्रक्चर होता है टेट्राहेड्रल, और देन इज द टेट्राहेड्रल परमैंगनेट आयन, राइट? सो इट्स ए okay. Then the oxidizing nature of the permanganate ion. So here you can see the oxalate gets oxidized to CO2, then iron to oxidize to Fe3 positive, nitrite to nitrate, NO3 negative, and iodide to iodine. And now so as these gets oxidized it will lose electron. So these electrons are gained by the permanganate ion to give you magnet. In the second equation here it will give you manganese dioxide with +4 oxidation state, and in MnO4 third equation 8 positive, this will give you Mn2 positive. So with the different reduction potential, and we will be using the oxidizing power of the KMnO4 to oxidize iodide ions, then in B to Fe2 positive to Fe3 positive, then oxalate to CO2. सो एज यू हम ये आप सोच रहे होंगे कि इसमें ये ऐसी इक्वेशन कैसे याद रखेंगे. नहीं, ऐसा नहीं है. हमें बड़ी इसको सिंपल तरीके से स्टेप बाय स्टेप लर्न करना है. व्हाट इज़ ऑक्सीडेशन, व्हाट इज़ रिडक्शन, what is the meaning of oxidation, how this ion is getting oxidized, and what will get on the product side, right? So how do we get this H positive ion? So this all we will learn, though you have आपने इसको 11th क्लास में रिडॉक्स रिएक्शन में सीख रखा है, बट हम इसको दोबारा करेंगे और एग्ज़ाम में यही पूछा जाएगा आपसे. तो दीज आर द 2 इम्पोर्टेंट क्वेश्चंस. जीके बोर्ड में तो आएगा कि एक्सप्लेन KMnO4 एंड द पोटाशियम डाइक्रोमेट और इनको बैलेंस करना, ये एग्ज़ाम के, राइट? तो बोर्ड में भी आता है और कॉम्पिटिटिव में भी आता है. Okay students, so next we will do in the next class other topic, so I will learn more about detail in the class. You can ask me the doubts, right? Thank you. God bless you.